Hello, we're going to start Unit 5, beginning with 5.1, applying the primary trig ratios. Today is Monday, June 1st. Before we begin, I want you to grab your calculator. Make sure you're in degree mode, so DEG or DRG is the mode you'll need. If you need to, there might be a reset button on the front which you can depress, or a reset button on the back, okay? To know that you're in degree mode, you want to press sine 30 and it's supposed to equal 0.5. If you have a calculator like mine, you have to press the degree followed by the sine, okay? So if you have sine 30, so your calculator will have different buttons in whatever order, okay? So in a textbook, you might have the question called evaluate, and then you'd want to press 30 sine or sine 30. It doesn't matter what order, you just have to know what order it is for your calculator, and then 0.5 would be the correct answer, okay? Now, the other one would be find the value. Okay, find the value of the degree, or the question might say something like sine to the -1 equals 0.5, okay? So in that case, it might even have 1 over 2. I'll do 1 over 2 so that you know what you're doing. Okay, so my calculator requires me to press bracket 1 divided by 2 bracket. It converts it to 0.5. We know that 1/2 is 0.5. And then second sine, which is the inverse, and it finds me 30. Okay, so make sure that you have those values. Let's see if we have a highlighter here. Okay, so make sure you're clear on those two things. Note number 1, given a right-angled triangle, so right-angled is 90 degrees, okay, and 2 lengths, you can use the Pythagorean Theorem to find the third side. There are 3 versions of the Pythagorean Theorem, so I should have given myself a little bit of room. Okay, so to find C, and we'll go over what that is. Okay, to find C, you're going to use C squared equals A squared plus B squared. Now, you can reorganize that to find B. Okay, you're going to use B squared equals, if I want to know what B squared equals, I have to move this A squared over, and that changes the sign from a positive A squared to a negative. So it's C squared minus A squared. Okay? And then to find A, you're going to use, still using this original formula, if you want A on its own side, because that's what we're doing, is to find A. I move the B squared, which is positive here, over to the other side of the equal, and that changes the plus positive B to a minus B squared. So it's A squared equals C squared minus B squared. Okay, so these are just reorganized versions of the same formula, same equation, we'll call it. It is a formula, but we associate it as an equation. Okay, move that over. Yeah, you can see that. All right. So label the angles A, B, and C. Notice that they're capitals, okay? Now, across from any side, okay, so these are lowercase, so lowercase A, B, C are sides, okay? Uppercase uppercase capitals, angles are capital A, B, C. Now, you might already know from other classes, other teachers, that if I have A, little a here, then across from little a, going from the side A, right, it goes from here to here, that's the length of 5. Going across from side A is capital angle A, okay? And that's this space here, right? Okay, across length C, okay, so across length C, it's from here to here, between my pencil and my finger. Across from C is angle C. And we typically, if we're paying attention, we would make 90 degrees the side, or the angle C, okay? And it's the 90 degree symbol. And then across from side B, notice it's lowercase, and then across from side B is angle B. Okay, that's from here to here, right? So we want to find the missing side. So what side are we missing? We're missing C. Okay, so to find C, we're going to use C squared equals A squared plus B squared. Okay, we're going to sub in the values of A, which is 5, B, which is 12. C squared equals A squared, which is 5 squared, plus B, which is 12 squared. We're using BEDMAS here because we've already isolated the C, right? So 5 squared, wherever your squared button is, there's mine. So 5 squared is 25, plus 12 squared is 144. Okay, so you're doing exponents, okay, first before you do addition or subtraction, right? So 25 plus 144 is 169. And then you have to take the square root, okay, and C is equal to 13. But if you don't know, there's my square root button, 13. Oops. That's important, right? Once you take the square root of C squared, it undoes the square, okay? So it just becomes C equals 13. Didn't need to round. Values that have exact values, like lengths that are non-decimal, they're called Pythagorean triples, and there's a bunch of them, okay? All right, note number 2. Given a right-angled triangle, so now I'm going to put 13. That's one thing I want to do. Okay, so I have all 3 sides. Okay, note number 2. Given a right-angled triangle, we know that that's 90 degrees. There is also a relationship between angles and sides using the labels opposite, adjacent, and hypotenuse. So given triangle ABC, so ABC, using angle A as the reference angle. So this is a reference angle. We usually think of it as the marked angle. Okay, knowing that this is called the reference angle means that we're going to pay attention to this because it's going to control a lot of things. Okay, now angle A marked X and angle B marked Y, they're both marked, meaning that they've both given a symbol. But even if X wasn't here, we could just call this angle A, right? So we could call this angle A. B, we could call this angle B. We wouldn't have to actually use a letter for it if we didn't choose to do so, okay? So using A as the reference angle, label the opposite, adjacent, and hypotenuse in reference, okay, to angle A. That's extremely important for these two, okay? This is always across the hypotenuse, so it doesn't matter where angle A is, but it's extremely important that that angle A is first established as a reference angle. Okay, so it's marked, and you can just follow the instructions, right? So it says angle A, using angle A. Usually they won't say as the reference angle, right? But if they say A, then they're talking about it being the reference. Okay, it's inferred. So the opposite side, I should have italicized those. The opposite side is across from the referenced angle. Okay? The hypotenuse side is across from the 90-degree angle. Okay? And the adjacent side is left over next to the reference angle. Okay? So notice that I've done this on purpose in this order. Always label the opposite side. So because the opposite side is across from angle A, okay, the space between my pencil and my finger is called opposite, okay? And we could even go opposite to angle A, okay? It's very, very important. Across from the 90 degrees, okay, is your hypotenuse. And I shorten it to hypotenuse hype. Okay, you'll already know that if you've done this before in grade 10 academic, you've already done this before. So hypotenuse is across from 90 degrees, okay? And then the adjacent is the leftover. So the only leftover side is here. And notice between my pencil and my finger, it is next to the angle A, okay? So this is called the adjacent. Maybe move this over. Don't need to write out the whole length of the word. Okay, so opposite, OPP, hypotenuse or HYP, adjacent ADJ. Okay, those are the short forms. Now, in labeling these, we can do the following. We can talk about the relationship between one angle and two sides, which are called the primary trig ratios. The primary trig ratios include 1, the sine, we'll use angle A for this purpose, so it's the sine of angle A is equal to the opposite side divided by the hypotenuse. Side, okay? Now very quickly we take the first letter of each of these words and we call this so. Okay? SOH. The second one is the cos or cosine of angle A is equal to the adjacent side. You're going to have to remember these. I do give them to you on assessments, but if you can remember them, they're easier because they're at your fingertips. Okay, so the cos is equal to the adjacent A over the hypotenuse H. So first letter of each word is ka, right? So ka, and then 3 is the tan of angle A, or the tangent of angle A is the opposite side over the adjacent side. Okay, so tan is TOA, and that's TOA. So the trig ratios are known as so, ka, toa. So, ka, toa. for short. Okay? Example 2. State the primary trig ratios for angle Z and angle X, then find the value of each angle to the nearest whole number. Okay, so let's find angle Z. So angle Z is here. That's going to be our marked angle. Now because it's marked, okay, it's marked. It's the reference angle. Okay, marked. Then across from angle Z is this length of 5. Okay, so this is opposite to angle Z. Okay, across from the 90, this is the 90-degree symbol. Across from the 90 is between my finger and my pencil, so this is Z. That was dumb. Let's do little lowercase y, because it's really should be capital Y across from lowercase y. Okay, so let's go with hypotenuse, because that's what it is. Okay, 90 degrees, across from the 90 degrees. And then the adjacent is the leftover one, which is next to the marked angle. Okay, so adjacent. All right, so let's state the primary trig ratios. Okay, so for A, okay, so we're using Z as the marked angle. The trig ratio of SO is the sine of angle Z equals the opposite over the hypotenuse. Okay, so what is the opposite? So we're going to sub in the opposite, which is 5, and the height, which is y. So the sine of angle Z, opposite of 5 over y. Okay, so that's the one trig ratio. Okay, let's go with, we're not yet done with Z. Okay, so Ka is the cos of angle Z equals the adjacent over the hypotenuse. Okay, so cos of angle Z is equal to, we're going to sub in the adjacent here, which is 12, and the hypotenuse, which is y. Okay, so the cos of angle Z is equal to 12 over y. Right? TOA is the third, right? 1, 2, 3. Still using angle Z, okay? Using angle Z. So TOA is the tan of angle Z equals O, opposite, over A, adjacent. Okay, so we're going to sub in. We don't know what angle Z is, right? It's not given to us. We know the opposite is 5. And we know the hypotenuse is, opposite is 5, and the adjacent is 12. So the tan of angle Z is equal to 5 opposite over adjacent, which is 12. Okay. Now we know that in any equation, we need to know more than what we don't know. In other words, we can only have one unknown. So here, this angle Z is unknown and this angle Y is unknown. So, oh, goodness, that's sine. So it's not useful to find the value of the angle, right? Because we are unsure of two values. Here we're unsure of two values, but here we can find the angle. So we want to write a reminder to find the angle, press, it's either going to be a shift button or a second F. So shift or second F. Okay, so we're going to put a highlighter on that one. Okay, and we're going to find angle Z. Okay, so what we want to do is we want to say, okay, so angle Z is equal to the tan of the inverse, so that's the symbol that's going to show up in our calculator, bracket 5/12. Okay, so watch what happens. So I have to press my bracketed value, which is called the trig ratio. Okay, so bracket 5 divided by 12, bracket, it converts my 5/12 to a decimal, okay, and then my calculator has to have the second F, and when I do, it should have a little -1 up in the screen. Well, it does over here. It has the second F symbol, it's hard to see. Okay, and then I go tan. 22.61. 22.619, blah, blah, blah. I'm going to round to the nearest whole number, underline the 2. 6 is 5 or greater, so angle Z is equal to 23 degrees. Okay, now I've not done this question. I am out of room, but I'm going to use my lined paper. Okay, so here I'm going to have to find the trig ratios for angle X. Okay, so for example 2, angle X is the reference angle. Now, because the reference angle determines where the labels are, which is what we set up here, okay, I'm going to redraw my picture. It's Y, X, Z, this is 5, and this is 12. Notice they don't have any units here, so we could go units. Okay, this could be units. Okay, so if X is my reference angle, here is what I'm going to determine what is my opposite, right? So cross from the angle X, my pencil, my finger identify that this is the opposite side. Okay, cross from the 90. 90 never changes its location. In other words, it doesn't matter what my reference angle is, whether it's Z or X, my hypotenuse is still across from my 90. Okay, what you should see though is that 12 is the opposite in question B, where X is the reference angle, but in A, when Z was the reference angle, 12 was adjacent, right? So then the leftover side is the third side, and that's the adjacent, and it's next to, this is next to my reference angle. Okay, so just adjacent is next to the reference angle. So it is very important to notice that 12 is the opposite when I'm using X as my reference angle. But if Z is my reference angle, then 12 has become my adjacent. Okay, just like if in Z, right, angle Z, opposite is my 5, and when X is my reference angle, 5 is my adjacent. So those labels switch depending on where my reference angle is. Okay, so I want to use my trig ratios of SOHCAHTOA. Okay, so those are my reference angles, or my trig ratios. Okay, so my trig ratios. Okay, so those are my 3 trig ratios. That was the whole question. And they use the word primary. We sometimes skip that word because we don't use the word. It doesn't mean that it's not understood to be the first initial values, okay? All right, so let's go. Okay, so is the sine of the reference angle, which is angle X, is equal to O for opposite, H for hypotenuse, okay? Ka. I better not go to Ka because I'll lose some of you. Okay, so let's do sub opposite. What's the opposite length? It's 12. And the hypotenuse is nothing. And they had, well, we changed it to y. So we're going to let it still be y. So the sine of angle x is opposite of 12 over hypotenuse, which we said was y. So we changed that to y because it has to be across from the angle y. So Ka is cos, C for cos, of the angle x is equal to A, which is the adjacent, divided by h, which is the hypotenuse. Still going to sub in the values of adjacent, which is 5, okay? Hypotenuse, which is y. So the cos of the angle x is equal to 5 over y, okay? So that's my one trig ratio, it's my second trig ratio. Then my third t is tan of the angle x equals O is opposite, over A, which is adjacent, subbing in the opposite, which is 12, the adjacent, which is 5, okay? So tan of angle x is equal to 12 over 5. Now, like we did in angle Z, we looked for what we could use, okay? So right here, there's two unknowns, won't work. We can't find angle x because we're supposed to find the value of each angle, okay? Right here, we have two unknowns. It won't be possible to find the angle because we have two unknowns as opposed to just one. Here, we can find angle x because we have one unknown,